Hello students, in this video I am going to teach how the regular expression can be converted into DFA. There are two types of converting regular expression into DFA. One is epsilon closure method or indirect method, in which regular expression can be converted into NFA first, then NFA is converted into DFA. In second method, regular expression can be directly converted into DFA by means of parse tree. This is otherwise called direct method. First we discuss about the regular expression can be converted into DFA by means of epsilon closure method. This is otherwise called indirect method. In this problem, the given regular expression is A or B whole star ABB. There are 6 steps needed to convert this into DFA. First one is write the NFA for given regular expression. Second one is find the epsilon closure of the starting state. Third one is apply move function of obtained state with input elements. Here the input elements are A and B. Then repeat the step 3 up to all the new obtained states. Then draw the transition table. Finally, minimize the result with final DFA. Let's see the steps one by one. First step is write the NFA equivalent. This is the NFA equivalent diagram for given regular expression. After drawing the NFA equivalent, you should check the correctness of the regular expression with this transition diagram, whether it is satisfy all the possible tokens generated by regular expression. Then we have to go to the next step. The second step is write the epsilon closure of starting state. Here the starting state is 0. First write what are the value present in the epsilon closure set, that is 0. First directly write the 0. Then find how many epsilon states are there from the 0 state. So from the 0 state, 1 is the epsilon state, then 2 and 3, and from 0, 7th state. So I write 1, 2, 4 and 7. I named this state as A. So the second step is over. Then I am going to move the third step. Third step is nothing but apply move function with input symbols. Here the input symbols are A and B. So apply these two input symbols into set A. So I write like this. Move capital A comma small a. Like this I can also find move capital A comma small b. First I find move capital A comma small a, in which I want to find what are the states involved in a input symbol A. So first I check the 0th state. There is no A from 0. So I ignore this state. Then I take the state number 1. From 1 there is no A is there. So I ignore this state. From 2 A is there, it reached the state number 3. So I write 3. Then from 4 there is no A is there. From 7 A is there, it reached the state number 8. So I include 3 and 8 here. Now I find the epsilon closure of 3 and 8. The first step is write 3 and 8 directly. Then I find what are the epsilon states from these two states. So from 3, 6 is the epsilon state. Then from 6, 1. From 1, 2 and 4. Then from 6, 7 is also a epsilon state. So I write 6, 1, 2, 4 and 7. I compare this state from the previous state. So this is new one. So I named it as B. So move capital A comma small a is over. So I repeat this for small b. So from this state I want to find how many states are using input symbol B. From 0 there is no B is there. So I ignore it. From 1 there is no B. From 2 there is no B. From 4 B is there. It reaches the state 5. So I include the number 5. From 7 there is no B is there. So there is only one value is called 5. So I want to find epsilon closure of 5. First I write the 5 value directly. Then from 5 I want to find how many states using epsilon. So 6th state is there. So I include 6. From 6 I can write 7. Then 1, 2 and 4. So this is the new state. I compare it from the previous state and A and B. So this is new one. So I named it as C. So like this move function A comma A and A comma B, I want to find the move function B comma A and B comma B, C comma A and C comma B. So I repeat this third step up to all the new states. So now I want to find the move function capital B comma small a. So the capital B state is listed here. From this I want to find what are the states using input symbol A. So from 3 there is no A is there, so I ignore it. From 8 there is no is there. From 6 there is no A. From 1 there is no A. From 2 A is there, it reaches the state 3. So I include 3 is here. From 7 A is there, it reaches 8. So from this set B, 3 comma 8 is the result. So I want to find the epsilon closure of 3 comma 8. I already found the epsilon closure of 3 comma 8, that is here. So this value is nothing but B state. So I can give the old name as B. Then I want to find the move function of capital B comma small b. So from the third state there is no B is there. From the 8th state B is there. So it reaches the value 9. So I write 9 here. From 6 there is no B. From 1 there is no B. From 2 there is no B. From 4 B is there. It reaches the state 5. So I include the 5. From 7 there is no B. So I ignore this one. So for move capital B comma small b, I can get 9 and 5. Now I find the epsilon closure of 9 and 5. First I write directly 9 and 5 here. So from 9 and 5 I want to find what are the possible epsilon state from 9 and 5. So from 9 there is no epsilon is there. From 5 epsilon is there, it reaches the 6. From 6 I include 1, 2, 4. From 6 I also include 7. So I write all these states. This is the new state, so I named as D. Now capital C and capital D states are generated. I apply move function. I repeat the steps. So repeat the same operation, we can get this value, and apply move function to the D, you can get this value. Now the new value is generated, that is called capital E. You need to apply move function for E, the input symbol A and B. So you can get this value. Finally, list all the generated states. Using this value only, we can draw the transition table, that is the step number 5. First we draw the empty table like this. First fill the generated states. The states from A to E. Then write the input symbols as columns. From this list, compare capital A and small a. We can get the set B. So I write B here. Then compare capital A and small b. We can get capital C state. So I write C here. In this way, fill all the state values. This is called drawing the transition diagram. From this diagram, we can create a DFA, but before that, we can check whether any possibility for reducing this state. That is the last step called minimizing the transition diagram, in which we can write the states in a single group named as pi. From this list, we should find the end state. Here the end state number is 10. So 10 is present here only. That is the state number E. So E state is the end state of DFA. So I can split the group where the end state is a separate one. Now there are two groups are available. One is A, B, C, D and E. Second, compare the first state into remaining states. So I first compare A into B. During the comparison, I want to check whether B state is present in the same state of A or not. Same state means output of B may be same as A or present in the same group. So BC and BD both are present in the same group. So I conclude A and B are in same group. So I do this comparison now for A and C. A and C is BC, so both the output are same. So I conclude A and C are in same group. Then I compare A and D. A output is BC, D output is BE. So E is in different group. So I treat D is in a different set. So I write like this: ABC in a one group, then D is a separate group, and write the previous one. Now I repeat the scanning again. Now I compare A and B. So AB is BC and B in BD. Now the D is in different set, so I treat B is in different group. So I write like this: AC in a single group, B is a separate group, and D and E. Now I compare A and C. A and C is the output of A is BC, output of C is BC. Both are same. So no need to mention C separately. So I remove the row C. So I can redraw the transition table like this. So instead of C, I can rename it as A. So finally I rewrite this table. So this is the minimized result of transition table. From this I can draw the DFA. So 4 states are available. So I draw the 4 states in which each state is the last state because it contains the 10th state number. So I double circled, and A is the starting state. So I put the arrow symbol. If I want to reach from A to B, the input symbol is A. So I can draw like this. If I want to reach A to A, the input symbol is B. So I draw like this. From B to B, small a. From B to D, small b. From D to B, that is D to B, small a. From D to E, small b. E to B, that is E to B, small a. And E to A, small b. So this is the DFA diagram. So in which some overlapping lines are there. So I shift this state here. Now we can get the clear transition diagram. Instead of A, B, D, E, I can also name as numbers, that is 0 to 3. So this is the solution for regular expression into DFA. Thank you.